Hello guys, my name is Eduardo Graziano and today I will be teaching you about the unit circle. Before we can solve any problems, we need to first take a look at the unit circle. Like any other circle, it is 360 degrees. We can see that at this line, it is labeled at 0 degrees and it is also labeled at 360 degrees, meaning that it starts and ends here. We can also see there's a parting throughout the circle. We can see there's 30 degrees here and then 15, 15, 30. And then we can also see here is 30, 15, 15, 30, and this repeats throughout the whole circle. 30, 15, 15, 30. Well, another thing that we can see about the circle is that it has radians. This is another way to write degrees, but it's in radians. It's just the same thing, but written in a different way. And then we can also see that the circle provides us with different points in an XY graph. These are the points of the circle from 0 in an XY graph. So if it's on the upper right side, it means it's on the first quadrant, so the x and y are both going to be positive. Then on this side, if it's on the second quadrant, it's going to be negative x, positive y. And this changes throughout the whole thing. Just you gotta remember that here this represents x and this represents y. It is also really important to remember that cos, sin, and tan have different meanings. For example, cos, when they're asking for cos in a problem, they're asking for x. Cos of a real number they're asking for x. So let's say cos 120. Then you go to the unit circle and you look for 120, and cos will be the x right here. So now we can take a look at what sin. Sin means y, and tan means y over x. Okay guys, now that we have learned some basic information about the unit circle, let's take a look at the first problem. Here we have sin 210. Now we know that sin equals, it means y, it represents y. And 210 is just a degree in the unit circle. So let's take a look at the unit circle and we can see 210, it has its point, right? So we're going to pay attention to y, alright? So y in 210 will be negative 1 over 2. So that will be our answer for this question. It will literally be negative 1 over 2. Okay guys, now we're gonna see a problem a little more complex. Here we can actually see that they're actually asking for the same thing that we did before in the first problem, but a bit more steps. They're asking to find cos 60, so just as we did before, we're gonna find the point in the unit circle, cos 60, and that's the point, 1 over 2, comma, radical 3 over 2, and we can see I wrote it down over here. We can also appreciate they're asking for cos, which is the x, so that's why I circled this one. Now sin 30. We look for the 30 over here, that's the point, which I wrote down over here, which is radical 3 over 2, comma, 1, 2. We can actually notice that they're the same points, just inverted. And now they're actually asking for y because of they're asking for sin 30, and that's why I circled the y. Now that we grab these 2 points that we're actually asking for, we put them, they're asking for to add them up together. We put a plus sign in the middle, and 1 over 2 plus 1 over 2 is equal to 1, and that's our answer. Hey guys, now we're gonna see this video a little bit more complex with a little bit more steps. It's actually pretty much the same thing, just that instead of using degrees over here, we're actually using radians. As I said before in the introduction, radians are just another way to express degrees. So as I pointed out over here, pi over 4 actually means 45 degrees, and we can actually confirm this on the unit circle. 45 pi over 4. And same thing with the other one, pi over 2, 90 degrees, and as I pointed out over here, pi over 2, 90 degrees. So now that we know where pi over 4 and pi over 2 is, let's get the points that we need. So for this, we're going to need the unit circle. So first, let's start with pi over 4. Pi over 4, and they're asking for cos, so the x of pi over 4. Go to pi over 4, that will be radical 2 over 2. So that's the points. The x, that's why I circled the x, and it will be radical 2 over 2. And then negative, because it's a negative, we're subtracting. And then let's find the other point. X of radical of x of pi over 2. Pi over 2, x, the x will be 0. So from the 2 points over there, 0, 1, 0, 1, we need the x, so that's why I circled the 0. So it will be radical 2 over 2 minus 0 equal to radical 2 over 2, and that will be our answer. Hey guys, now we're going to take a look at a harder and more complicated question. Here we can notice that this is like a hard to understand equation, but it's not that hard. First, just follow the easy steps to complete this equation. First, identify that we have the sine x. Now you're going to solve for that sine x. So how are we going to solve for x? We're going to first add plus 1. Okay, now after we've done that, we put it on this side, add it here, add it there, we put it on here. Now divide 2. Sine x equals 1 over 2. What you do for one side, you do it to the other side. After that, you already have the equation that you were looking for. Okay, here you can notice that it actually looks a lot like the problems we were doing before in medium, but reverse. Like they're actually giving us this that we were actually trying to find the other problems and asking for what we already had on the other problems. So let's take a look at the other problems. Remember how we had this, but they were actually asking for what it will equal to. So here is the same thing, but the other way. So how do we do this? Okay, there's a trick. First, there's a trick, which for this we have to actually use the all students take calculus trick. I'm gonna pause the problem to explain this to you. All right, here, what does all students take calculus stand for? Okay, all students take calculus. That's why in the first quadrant goes all, then students in the second, then take in the third quadrant, and then on the fourth quadrant, calculus. All stands for all of them. Sin, cos, and tan are positive. They're all positive. Then students stands for sin, since it starts with S. Sin is positive. And then take starts for tan, since it starts with T, and tan is positive. And then calculus starts for cos, and cos is positive on this quadrant. Okay, so now that we know this, we're gonna go back to here. We can recognize that actually sin x equals 1 over 2. This is a really common point that we've seen in the unit circle before. So let's take a look at the unit circle and I'll show you. Here, 1 over 2. We can see another 1 over 2 over here. We can see a 1 over 2. So there is not a coincidence. It's supposed to work like that. You were actually supposed to get 1 over 2 after you solve for sine x. Okay, now we're gonna recognize that it is positive, so we're gonna do the all students take calculus, and we're gonna recognize that it's sin. So we're gonna look for all the places where sin is positive. So here only all are positive, so do we mark that one because sin is included there. Then sin starts for students starts for sin, and sin is positive, so we mark that one. And then take calculus, only tan and cos are positive here, so we don't actually recognize those. Now that we know that, we're going to look where sine is positive in these quadrants. So we know sine, which is y is positive in pi over 6, so that's one of the answers. And then we're gonna look for the other quadrant where y is positive, and we recognize right here 5 pi over 6, and that's one of the answers too. And then plus 2n pi, and you're actually supposed to add this to all the problems that are like this and they're sin or plus. When it's tan, you don't add this. You actually add just n pi, not the 2. Okay guys, now we're gonna take a look at the last and hardest problem. Here we can actually notice that it is the same basic problem as before, just a little bit more steps. They're asking for sin x equals to something. So we're gonna find what sin x equals to what. Okay,
we're gonna actually get the sin x. There's actually two, so we actually get them to the same size. We're gonna subtract here, and that's gonna be equal to radical 2 equals to negative 2 sin x. Now we're trying to get sin x alone, so we actually divide the negative 2. And what we do to one side, we do it to the other side. So that we're going to divide this side by negative 2. And now we're going to get radical 2 divided by 2 and it's a negative equals to sin x. I mean, I'm pretty sure you guys recognize radical 2 over 2 as one of the points that we've seen before. So let's see where it is in the unit circle. We're gonna see that it's right here, right here, right here, and right here. But it's a sin, so it's a y, and it's negative. So we're gonna find where using all students say calculus, we're gonna find where sin or y is negative. So we know all here, all positive, so it can be here. We know sin is positive here, so sin is going to be negative in here and here, because tan is only negative here, it's only positive here, and cosine is only positive here, leaving sin negative. Okay, now we recognize radical 2 over 2 from this equation in the first quadrant. We can actually use pi over 4 as the reference. Even though this is no part of a final answer, we recognize that radical 2 over 2 belongs to pi over 4 on the first quadrant. And okay, now that we know that our answers are in tan and cos, we're actually going to take a look at the unit circle and find out where they are. Okay, we're going to find out where negative 2 radical, now we're going to find out where radical 2 over 2 negative is in quadrant 3 and quadrant 4. So we're looking for a negative. Oh, it's on both sides, but remember they're asking for sin, so we ask actually this one, sin, and that's 5 pi over 4. So 5 pi over 4 is part of the answer. Then comma, I'm gonna find the other part, which is in quadrant 4, and it's 7 pi over 4. As you can see here, sin, it's the answer we got, negative radical 2 over 2. So 7 pi over 4 plus 2n pi. As I said before, it's always for sin and cosine.
And why do we put 2n plus 2n pi? And why do we put 2n pi?